Welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great webinar on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to listen to it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for our speaker, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your question. And finally, at the end of today's webinar, we will be doing a drawing for 3 $50 Amazon gift cards. So stick around, hopefully you'll be one of our 3 lucky winners. Okay, with that, we'll go ahead and kick off today's webinar, which is open source security, how to lay the groundwork for a secure culture. Our speaker today is Bar-Gil, who is product manager over at WhiteSource. Hi, Guy, how are you? Thanks for joining me.
Hey, Charlene, thanks for having me.
Awesome. Well, I know you've got a great presentation, so I'm gonna put myself on mute and just let you get right to it.
Great, thanks. So hi, everyone. Welcome to Open Source Security, how to lay the groundwork for a secure culture. As Charlene mentioned, my name is Bar-Gil, and I'm a product manager at WhiteSource. And so what we're going to talk about today, actually what we're going to do is I'm going to tell you 2 stories. The first about the breach of a company called Equifax, and the second about the M&A of 2 companies, which we'll call small comp and large comp, just for the sake of anonymity. And after each story, then we're going to discuss some of the lessons that can be learned from those stories. And then in the third section, what we're going to do is we're going to talk about how you can practically implement some of those lessons into your company's unique processes, using something that I call the 4 steps to open source security. And we'll see more about what that means later on. So just before I get started, I'd like to introduce myself. So like I mentioned, my name is Bar-Gil, and I work as a product manager at WhiteSource, where what we do is we help companies manage their open source software from both a security and a compliance perspective, allowing them to focus on what's important. And just a little bit about me, I have 2 dogs and a cat. And in my free time, I enjoy both watching and playing pretty much all types of sports. Other than that, I enjoy reading, mostly on the weekends, and I think that literally all of my vacation days are spent traveling. Anyways, okay, let's get into the presentation. So the first thing I'm going to do is I'm going to tell you guys about the story of a company called Equifax. And just before we get started on that, I'd like to give you a bit of background on the company. So Equifax is a consumer credit reporting agency, meaning that they assess the financial health of US citizens. And basically what that means is that they determine things like how easy or how difficult it is for you to take out a loan from the bank. And the reason that's important is because for Equifax to make those types of decisions, they have to collect very sensitive information, including names, addresses, social security numbers, and even credit card numbers in cases where people paid them directly to get their credit scores or something like that. And well, Equifax is a rather large company. They have 800 million individual consumers and over 90 million businesses that they collect and aggregate information on. And in addition, they're publicly traded in the New York Stock Exchange with almost 10,000 employees and a little bit over $3 billion in revenues from 2016, of course, which is the year prior to the breach. And so now we're jumping forward, or actually backwards, to September 7, 2017, where Equifax announces that attackers had exfiltrated hundreds of millions of customer records from their databases, and that all of it was made possible by a publicly known vulnerability, which is dubbed CVE 2017-5638 in Apache Struts. So Apache Struts is an open source framework for creating Java web applications, which in Equifax's case, it was used for their customer support portal. And the vulnerability allows for a remote code execution through the web application, through Equifax's customer support portal. And basically what that means is that malicious code could be embedded into the customer support portal, and then it would run on the server that's hosting the portal, which is obviously bad. But like major plane crashes, so major InfoSec disasters are typically the result of multiple points of failure and not really one little mistake. And so let's get into the details. So on March 9th of 2017, of course, the CVE was published, and at the same time, the Apache Software Foundation, which are responsible for maintaining Apache Struts, released a patch for the vulnerability. And that's usually the case, that both the vulnerability and the patch are published at the same time. Because if the case were that a vulnerability is published without a resolution, then attackers would basically just have a field day, right? And actually, Equifax were quite responsible here, and they had their administrators, they told their administrators actually to apply the patch to any affected systems. But the patch fell through, meaning that it wasn't applied for unknown reasons. And there are several speculations as to why that happened, but there's not really a concrete reason. The important thing is just that in the end, it wasn't applied. And only one day later, actually, on March 10th, hackers had already gained access to Equifax's systems. And about a week later, on March 15th, Equifax actually had their IT department run a few scans to identify any systems that were left unpatched. And probably for similar reasons that the patch wasn't applied, these scans fell through as well. But again, just they didn't happen. That's what's important. And now we're jumping forward almost 2 months to May 13th, which is when hackers actually begin exfiltrating the data. And you may notice that the next point of the timeline is almost 2.5 months later. So you might be thinking, wait, so all that data was extracted or being extracted for 2.5 months without Equifax knowing anything about it? And well, without getting into too many details, what happened is that Equifax failed to renew a public key certificate, meaning that their internal traffic wasn't being inspected. They weren't able to decrypt it pretty much. And only on July 29th, when Equifax finally renews that expired public key certificate, were they able to inspect their internal traffic, and that's when they first learned that they were breached. So about 4.5 months after the initial breach. And it took them another 1.5 months to actually publicize the breach. And again, lots of speculation as to why this happened, but no real concrete reason. So you can see that it took them about 6 months from the moment they were breached until they publicized it. And a little bit about the aftermath of the incident. So it was immediately labeled as one of the largest corporate data breaches in history. It affects about 145 million people, and they actually filed a class action lawsuit on Equifax, and it was officially approved about a month ago. And Equifax had to spend about $3 billion only on upgrading its security tools and in resolving the consumer claims of that class action lawsuit. And I just put in this New York Times headline here that the Equifax breach was caused by a lone employee, according to their former CEO, just to emphasize the implications that one person's mistake can have. And so what can we actually learn from this story? What can we take away from it? The first thing is to act fast, right? As soon as an exploit is published, it's public for everyone, not only for the people who have to apply the patch, but also for people looking to exploit it. And so it's extremely important to act fast, right? Equifax was breached only 1 day after the vulnerability was published. The second thing is that you have to continuously monitor your code, right? There are about 300 new vulnerabilities being published every month, and these newly published vulnerabilities are in commonly used open source components, right? Nobody's going to be searching for any vulnerabilities in that one GitHub repo you opened up as a student. And it's actually important to continuously monitor, not only to discover new vulnerabilities, but also to find out if existing ones weren't properly remediated. Like in the case with Equifax, where a week after the patch was applied, or the patch was released actually, then their administrators were told to scan and make sure that all the systems were patched. And number 3 is to get the basics right. Right, Equifax was breached by failing to patch a basic vulnerability despite having all the procedures and all the security systems in place. They spent millions on security gear, but because it was poorly implemented, it was basically ineffective. Okay, so moving on to the second story. Now we're going to tell the story about an M&A of 2 companies, which are not real companies, right? Small Comp and Large Comp. The names are fictitious, so if you look them up, you won't find them, just for the sake of anonymity. Okay, so a little bit of background. Small Comp is a small software company, and Large Comp is an enterprise scale software company. So Large Comp is acquiring Small Comp. And as part of an M&A between 2 companies in the software world, SmallComp was required to do an open source audit, basically meaning that they had to declare all their open source dependencies to LargeComp so that LargeComp can make sure that none of those components are problematically licensed and that SmallComp are complying with all the terms. And for anyone who's not familiar, each open source component comes licensed under certain terms. Right? Some licenses are very permissive, like MIT, which requires you to include the original copyright and the license when you're attaching that open source component to your code. And some licenses are what are called copyleft licenses, which is actually a term that was coined especially for the open source licensing world, and it means the opposite of copyright. So if copyright means that all rights are reserved, then copyleft means that no rights are reserved, or in other words, that everything attached to that component now has to be open sourced. And an example for a license like that is the GPL license. You may be familiar with it. And so SmallComp actually found a dependency that was licensed under AGPL, which is an even more restrictive version of GPL. So it's a copyleft license. And basically what that means is that SmallComp has to open source any code that's attached to that AGPL component. And as soon as LargeComp learned about this, they immediately took action. Basically what they did is they put $4 million in escrow under the following terms. First of all, SmallComp has to remove any trace of that AGPL from the software. And the second thing is that 80% of SmallComp's customers have to deploy the updated software, so the software without the AGPL component, to production. And all of this has to be done within a 2-year time frame, right? And the development and deployment related costs are going to be taken from the escrow. So if development and deployment related costs are $500,000, then after the acquisition, the shareholders of SmallComp will receive $3.5 million, and LargeComp will keep $500,000 from the escrow. And it may seem like these terms aren't a big deal. I mean, it's only exchanging one component from the code base and deploying the software. But in reality, the problem isn't that easy to solve. And there are two main obstacles here. The first is that development and QA time was estimated at 1 year for one person. And SmallComp is a small company with very limited resources, so they can only afford to put one person on this issue. And the second thing is that SmallComp's customers are hospitals. And in hospitals, if anyone's ever worked with them, then you'll know, solutions are often manually deployed, and technicians are required to train the staff. So SmallComp's customers are spread throughout the globe. And like I just mentioned, then they're a small company with very limited resources. So it's not like they can just send their technicians to all of their customers at once. So sending a technician, training the staff, and persuading the hospital to deploy the software from the staging environment to production, each of their customers' premises, is in no way an easy task. But actually, unlike the Equifax story, there's a happy ending here. SmallComp was able to fulfill the terms of the escrow after it took them 1 year and 8 months, actually. And all that was lost was the cost of development and deployment. And yeah, I just wanted to have one positive story in my presentation. I couldn't have them both be negative, so they did it. Good for them. And anyways, what can we take away from this story? How do we avoid being in this situation? So there are 3 steps here, and the first is to set clear policies for the whole company in regards to licensing. Right? By setting clear company policies, you're really taking the first step towards open source compliance. And the second step would be to communicate those policies to developers, who are the people in the field. Right? If you don't communicate the policy to the developers, which they're the ones bringing in the open source components, then how can you expect them to follow those policies? And the third one is to enforce, right? You have to make sure that your policies are being enforced. Even though you trust your developers, right? No doubt, everybody makes mistakes. And it's important to double check the licenses on the open source components that you're using, just to make sure that nothing sneaks by, right? It's always best to double check. So moving on, now that we understand some of the challenges and some of the risks, we can talk about what practically needs to happen in order to address those challenges and to mitigate those risks that have to do with integrating open source into your software, of course. And the most important thing is to get the basics right. And in order to get them right, then you have to have a really good understanding of them. So in order to do that, I'm going to talk about something called the 4 steps to open source security, okay, which is basically going to be 4 steps to take your software from a place where the components you're using and the vulnerabilities that are associated with them are invisible to you up until you fix the issues, and only the vulnerabilities remain invisible for a completely different reason. So step number one is creating transparency. Transparency is really the baseline to everything, because how can you detect and solve issues in your open source components if you have no idea what they are, right? So you have to understand exactly what you're using. And there are three main ways to attach open source components to your code or to consume open source components. And the first and most straightforward way is as a direct dependency. So let's just say, for example, you're a developer and you're developing in Java, you use Maven. So you'll just hop onto Maven Central, right? You'll find a component that fits your needs and you'll add it to your POM XML. And as soon as your application is built, then that open source component will be attached to your code, pretty much. And each open source component, or many open source components, I'll say, rely on other open source components, right? So those open source components that your open source component relies on are called transitive dependencies. It's not an open source component that you brought in yourself, but it's the open source components that the one that you did bring in that your direct dependency depends on. And the last thing is source files, the last way to consume open source. And source files are basically undeclared dependencies. The way that they get brought into your code base is usually a developer will just be browsing GitHub and they'll find some source file that works for them that fits what the problem they're trying to solve, and they'll copy and paste it into their code without declaring that dependency in the POM XML, for this example, in their manifest file. And actually another note on transitive dependencies, they're just as important as direct dependencies, right? It's not like their vulnerabilities are any less exploitable or that their licenses have to be complied with any less. They have, from a vulnerability and licensing standpoint, they have exactly the same status. And just to emphasize why using source files or undeclared dependencies in your project is a bad idea, I actually want to play a quick game, but since this is a webinar, then I'll just play the game and you guys can watch. So right now, I'm an open source scanning solution, right? And I'm inspecting a program written in Java, hence the jars here. And I'm trying to understand what this component that I just scanned is. It's the one on the left. So I scan this component, I find it, and now I'm going through my database, which is the 8 jars on the right. And I come across a component that matches perfectly the one I just scanned. It's the one on the top right. And I know it's a perfect match because, well, first of all, they look exactly the same. And also none of the other jars look anything like it. So there's basically no way that I can get mixed up here. But what about now? The next component I scan comes in. And as you can see, it's not a jar this time, but just some Java beans or source files. And so I'm looking through my database, and unsurprisingly, I can't determine where these Java beans originated. They could be from any one of these jars. And now the fact is that the same source file can be used in tens of different open source projects. But identifying the original jar is crucial in order to understand what licensing terms I have to comply with and what the component's copyrights are. Okay, so, well, now we're done playing the game, and I hope it's clear to everyone that matching source files is much more difficult and much less accurate than matching the full component. But anyway, it's still extremely important to match them, right? It's important to understand the difficulty and that the match isn't always 100% accurate and may involve some of your, may involve you as well. So moving on to step number 2 now, detecting potential issues. Now that you understand exactly what open source components you're using, you want to match those components to the most comprehensive database possible. And this database is a database of both vulnerabilities and licenses. And just a few examples of what should be in one of these databases is, first of all, published CVEs. So for whoever's not familiar, a published CVE basically just means it's an officially declared vulnerability. You can find them on the CVE website. If you type in CVE website in Google, it'll be the first link you find. I checked, so I'm 100% sure. And second thing is vulnerabilities published in security advisories. So some package managers like NPM have their own security advisories dedicated to telling people about security-related issues in their components. So you want to bring in vulnerabilities from there too. Not all of them are published as CVEs, or it might take time to publish them as a CVE. A third thing is vulnerabilities detected by research teams. So some open source management solutions have research teams behind them who inspect, for example, GitHub commits or GitHub issues for mentions of potential vulnerabilities in the repositories. And if, for example, an issue is found disclosing a vulnerability, then the research team will add that vulnerability to the database. And these types of vulnerabilities aren't found in security advisories or as published CVEs. And from a compliance perspective, you want to make sure that there's thorough license detection in the database you're matching to. So first of all, you want to make sure that there's no nested GPL or anything in your code base, because as we saw in Smallcomp's example, then even a transitive dependency, for example, that's licensed under GPL will effectively, it'll impact the direct dependency and then impact your code as well. So you want to make sure that there's no nested GPL. And in addition, you want to make sure that you can match source files to the libraries they came from to make sure that those licenses are complied with as well. So moving on to step 3, now that you have, for example, 300 vulnerabilities in front of you, right? You understand exactly which open source components you're using. You detected all the possible issues with them. So now you're staring at 300 issues, for example. How would you prioritize those? Would you just start randomly? I don't think so. And so I have a few ways here that you can prioritize the issues. By the way, these are in no specific order, just a few factors that I think people should take into consideration. And yeah, so the first one is business risk. For example, you definitely want to prioritize a vulnerability in a system that has access to sensitive customer data, for example, or a system that's deployed to customers and can exploit their systems or something like that. The second thing is exploitability. So you may have a vulnerability which is only exploitable if you don't have a firewall, for example, in your environment. And so if you do have a firewall, then that vulnerability can obviously be deprioritized for now, because it's not really exploitable at this moment. A third factor is severity, which is pretty straightforward. You definitely want to prioritize high severity vulnerabilities before low severity vulnerabilities. A fourth factor, availability of fixes. If you have a fix available right there in front of you, then you probably want to apply it. It'll only take you a few minutes and just get rid of it. And the last factor is effectiveness. And I actually want to go into a little bit more detail about what I mean by that. So an effective vulnerability basically means that a call trace exists from the proprietary code to the vulnerable method in the open source component, right? So if that call trace exists, then somebody using your system can trigger the vulnerable open source method, and then that vulnerability is exploitable. But if no call trace exists and the proprietary code is not making any calls to the vulnerable function, then that vulnerability is not exploitable right now, and you'll want to deprioritize it. So you want to prioritize effective vulnerabilities first, and then ineffective vulnerabilities second. But it's not like these ineffective vulnerabilities can be completely disregarded, because in the future, then when you're expanding your application, you may start making calls to these vulnerable methods in the open source component. They're just not as urgent as the effective ones, because the effective ones can be exploited, well, right now, pretty much. And so actually, we did a study here at WhiteSource, and after testing about 2,000 Java applications, we found that 85% of all the detected vulnerabilities were deemed ineffective, which is a huge amount. So if we stay with our example from before of, for example, 300 vulnerabilities that you have in front of you now, so that would mean that 45 of them are effective, and well, 255 are ineffective, which makes prioritizing much easier, at least, at a first glance. And then you can get into some more details into how to prioritize those 45 effective vulnerabilities. And so now that you've prioritized all your vulnerabilities, then we can get into execution and actually remediating those vulnerabilities. And each vulnerability has, a different best path to remediation. Sometimes the best path might be to simply upgrade the component's version. So for example, if you're using, Jackson Databind 2.8 and the maintainer of Jackson Databind released a patch for that vulnerability in 2.9, then you'll want to just upgrade the version. It shouldn't be a big deal. But maybe, maybe there is no patch yet for the vulnerability. So maybe you'll want to change out the component altogether. Maybe you want to change it for a component with similar functionality that has no vulnerabilities attached to it. Or maybe you'll want to set up an external defense. So if we use our example from before with the firewall, so if you don't have a firewall in your environment and a vulnerability is only exploitable for environments that don't have a firewall, it might be easier to just set up a firewall and you could actually remediate maybe 10, 15 vulnerabilities at the same time like that. So to summarize, there are 4 steps pretty much to, I guess we can call it a vulnerability lifecycle, right? The first thing is to create transparency. You want to make sure that you understand exactly which open source components you're using. At this point, everything is invisible to you, or at least not everything is visible to you. The second step is to detect potential issues in those open source components. So you want to match against the most comprehensive database possible to detect every single possible issue. Step 3 is prioritizing those issues. And then step 4 is executing and actually practically remediating those issues. And now let's talk about implementation. So we've learned what it takes to go from understanding what you're using, right? So you've understood what you're using, you've detected any issues, and now you're remediating them. So now we can move on to understanding how to practically implement these steps into your company's unique processes. So what we're going to do is we're actually going to go over the same 4 steps from creating transparency to execution, but this time in regards to implementation in your company's processes. So once again, step 1 is creating transparency. And the first thing here is to identify the processes in your software development lifecycle, or the SDLC. The point is that you need to understand the path that software takes from when you start planning it all the way up until you're maintaining it, until it's in the maintenance phase. And so I actually have an example SDLC here. So you can see there are 4 steps: development, build, deployment, and maintenance. And obviously your companies will probably be more complex than this, but hopefully this gets the point across. So step 2 is actually detecting 2 things this time and not just 1. So the first thing is that you want to detect where you want to implement security checks, and then you also want to detect where you can automate those security checks. So you don't want to allow problems to flow from left to right in the SDLC. Right? You want to have security checks in between each step, and you want them to be automated. So it's actually a little bit small here, but you may be able to see that I wrote security checks in between each step here. And yeah, and it's important to have them automated. And I actually want to give you a short example of why that automation is important. So the way I've actually heard several companies who work this way, for example. So a developer wants to use an open source component, and so what he does is he'll send the link to that open source component to the security team. And now the security team has to understand a few things. First of all, they have to understand what the license of that component is. They have to understand if there are any vulnerabilities associated with that component. And they have to understand if anything about that component violates any company policies. And then after they do that, they have to do the exact same thing for all of the transitive dependencies of that open source component. And this sometimes delays developers for several hours, and even I've heard of examples of several days before a developer gets a response from the security team when they work like this. And obviously the developer, meanwhile, isn't going to sit around and do nothing. So he might just use that open source component and hope everything is okay. Or they might just wait with that task, move on to a different one until the open source component is approved. But as an automatic process, you can basically do the same thing in 10 seconds. You can use, for example, a Google Chrome integration, which as soon as you click on a link to an open source component, then what you'll see is, well, first of all, you'll see any vulnerabilities that are associated with it and its transitive dependencies. You'll see what it's licensed under. And if you have a smart system, then you can even set up policies. The security team can set up policies that developers can see if this open source component is violating right there, just in the click of a button. So it's definitely better to automate these instead of having them as manual processes. And I'm actually going to go ahead and give an example of how you can automate this step in each step here in the SDLC. So we just discussed development. You can use the Google Chrome integration, but another option you have here is to use an IDE integration. So anytime a developer pulls in a component, then a scan will run in the background, and it'll let the developer know if there are any vulnerabilities associated with it, what it's licensed under, if it violates any organizational policies, and basically the same information that we just got from the Google Chrome integration. And it'll do that for all of the open source components in the manifest file. So that's actually the advantage over using the Google Chrome integration. But it's really a personal preference kind of thing. I personally like the IDE integration, but your choice. And oh, by the way, the development phase here in my SDLC is from the second you start planning the software all the way up until right before you press push into the repository, right? Push the code to the repository. And so moving on to the next step, build, the boundaries here are from a second after you press push all the way up until you deploy. And there are lots of examples that I can give here, but what I'm going to choose to go with is repository integration. And basically, a way that this repository integration could work is, for example, as soon as a developer pushes code to the repository, then it can trigger a scan. And at the end of that scan, let's say you're using GitHub, right? So GitHub has a functionality called check run, which is basically, it lets you know, it can give you a failed status or a success status. And so it can trigger a failed status if any vulnerabilities were introduced into the repository, or a success status if no vulnerabilities were introduced into the repository in that sense, in that commit. And the reason this is extremely important is because, well, today teams could be pushing to the repository several times an hour, and it's important to understand exactly at which point the vulnerabilities entered the repository. And this gives you a resolution to do that by commit. And actually, the open source integration in the repository will, what it'll do is it'll open an issue for each vulnerability, where you can really drill down into the details of that issue, and you can understand if it affects you, and if it does, you can prioritize it accordingly. You'll have all the details in there. And some more advanced systems will even be able to open a fixed merge request automatically. So it'll check behind the scenes if, for example, if we go back to Jackson Data Bind 2.8 and we have the clean version of 2.9, then it'll automatically open a fixed pull request for you. And all you have to do is make sure it doesn't break your code, and then you can improve it, and the component will be basically upgraded from 2.8 to 2.9. So moving on to the deployment step, it's extremely important to scan here as well because, well, let's just say that, for example, you're using containers, okay, to deploy. So you may have additional vulnerabilities being introduced in the packaging of your software. And it's important to understand if that's the case. And this is actually a critical checkpoint because this is right before you're deploying to the customers, so, or to the users. And you want to make sure that no vulnerabilities and no surprises are going to reach them. And the last step in the SDLC, in my example SDLC, is maintenance, maintaining. And so if you remember from before, there are about 300 new vulnerabilities being published every month. And it's extremely important to continuously monitor your applications that are deployed to make sure that none of these vulnerabilities are affecting them. And you have to do this all the time. Like if you remember from Equifax before, it took only 1 day for them to be breached. And so you have to react extremely quickly. And okay, moving on to step number 3. So we've identified our company's processes. We've detected where we can implement security checks and where we can automate them. So step number 3 is prioritizing. And actually, when it comes to implementing into your company's processes, then prioritization takes on a bit of a different angle. It becomes about being disciplined enough to prioritize acting on detected vulnerabilities as early as possible, or in other words, shifting left in the SDLC. And this basically means prioritizing the action of fixing the vulnerabilities as early as possible and not allowing those vulnerable open source components to reach that last deployment checkpoint before actually implementing the fixes. And you might be thinking to yourself, well, as long as the vulnerabilities aren't deployed along with my application, then they can't really be exploited. So there's nothing major to worry about until then. And well, while that may be partially right, there are several other things to consider here. But I think the one that drives home the point most effectively is just how much it costs to remediate a vulnerability at each point in the SDLC. And so, yeah, you can see very clearly that the cost of fixing a security or a compliance issue rises very significantly as the development cycle increases. So you can see that in production, it's almost 100 times more costly to fix any defect with an open source component than it does in the coding phase. And that's why you want to integrate tools to help you detect those vulnerabilities or issues as early as possible. And there are many other benefits to shifting left beyond this, but I think that these numbers just make it extremely easy to understand. And, dollars are very intuitive. And so moving on to step 4, execution. So whose responsibility is it to actually, basically whose responsibility is open source security? And the way I see it, responsibility is on the organization as a whole. So the security team is responsible for setting policies, right? They have to tell developers which licenses are okay in their organization, which licenses aren't okay in their organization. Maybe low severity vulnerabilities are all right if the component is extremely important to them. And it's important for the security team also to educate the developers on these policies. They have to know what the policies are in order to comply with them. And the development team is responsible for the execution itself. So they're going to be the ones actually upgrading the component's version, actually changing out that component, and basically they're responsible for taking action. And there's actually one more responsibility for the security team that I didn't mention before, and that's to provide developers with the tools required to efficiently handle any open source related issues. And so there are lots of open source security tools that integrate with tools developers use on a day-to-day basis. And the way I see it, you don't want to force developers to deviate from the workflows that they're already used to. So you might as well make it easy for them and implement tools that fit into their native environments. And so to just quickly summarize this last part of the presentation, here are 3 things you can take away. And actually, they all start with E. I'm just noticing that. So it's extremely important to educate anyone involved in the organization on the basics of open source security and compliance, right? You want to make sure that you're speaking the same language. And okay, so number 2 is empowering teams by providing them with the right tools. So having the right tools in your organization is a key factor to success in the world of open source security. Right? Development teams should have access to tools within their native workflows, like we just mentioned, and security teams should have comprehensive management tools so that they can keep track of any vulnerabilities that are associated with the open source components in their organization, along with licenses, of course. And number 3 is to enable success by creating a shared mission. So in my opinion, one of the key factors to success, actually not only in open source security, but in general, is to work as a team. So try to make open source security and compliance a team effort, and everyone's going to have a better time that way. And to basically summarize the point of the entire presentation today in one sentence, just do whatever you can to make sure that you're not that guy. I mean, yeah, I think that speaks for itself. And thanks. Questions?
All right, great. Don't be that guy. I like that. Plenty of time for questions. So if you have a question, please go ahead and use your GoToWebinar control panel and submit it. And why don't we go ahead and dive right on here, dive right on in. Okay, the first one, at the beginning of your M&A story, you mentioned MIT is a permissive license, and GPL, which you called a copyleft license. Oh, okay, MIT is a permissive license, and GPL, which you called a copyleft license. Are those the only 2 types of open source licenses?
Okay, so that's a great question. And well, the way I see it, you can basically split open source licenses into 5 general groups based on their restrictiveness. I'll give a quick overview of each type just so you get the general idea. So, okay, let's start with the most permissive license type, which is called public domain license. And it basically means that anyone can modify and use the software without any restrictions, really. Also, an important note actually to make here is that an open source component that doesn't have a license attached to it is not automatically in the public domain. Okay, so I'm actually going to repeat that because it's really important. An open source component that doesn't have a license attached to it is not automatically public domain. The second category is, I guess we can call it permissive licenses. And the licenses in this category have minimal requirements about how the software can be modified or redistributed. And for example, that MIT license that I mentioned earlier would fall into this category, where you have to pass on the copyrights and the license itself. And I can't really think of a name for this third category, but the licenses that fall into this category allow you to link the open source component to your software without having to open source your proprietary code. But if you make any changes to the library, the open source library, or copy parts of it into your code, then you'll have to open source your code. And then the fourth category would be copyleft licenses, which, like I discussed earlier, require you to distribute any new works that are based on it under the same software license. So, for example, if a component's license might say, that the work is free to use and distribute for personal use only, then any work that you create on that would also be limited to personal use only. And then the last category is just a proprietary license, which is the most restrictive type. And basically, they're copyrighted and all rights are reserved.
All right, great. So here's another question for you. I've recently been looking into purchasing an open source management system or solution. So what are some of the main things that I should consider?
Okay, so actually this is something that I could probably make a whole nother webinar about. But basically the bottom line, I think, is that you want to make sure that the solution you choose makes it as easy as possible for you to cover the 4 steps that I discussed earlier. So it should be able to identify open source components that are consumed both as direct and transitive dependencies, as well as source files. It should have a comprehensive database encompassing everything I mentioned before. So I mentioned CVEs, I mentioned vulnerabilities from security advisories. You can have a research team behind it, and etc. And it should provide you with the information necessary to prioritize the vulnerabilities after you've seen them, and the information necessary for you to understand the best path to remediation. And in addition to that, it shouldn't be difficult to integrate the tools offered by that open source management solution into the tools and processes you already use within your company.
All righty, let's see, we got another one here for you. You brought up a few of the challenges in integrating open source into software during your presentation as lessons to be learned from the stories you told. So do you see any additional major challenges? That's a good one.
I don't know if I would call them challenges, but more things to look out for and make sure that you're aware of. In my personal opinion, the biggest challenge of integrating open source into any software is just simply the fact that somebody else wrote the code, and you have to trust that they wrote the code well and with a minimal amount of bugs and vulnerabilities. But actually, if you don't just blindly insert any open source component into your software and you do a bit of basic due diligence, like checking beforehand if there are any known vulnerabilities associated with that component, then it shouldn't really be too big of a concern. Maybe I'm just paranoid, I don't know.
Well, you know what they say about being paranoid. So anyway, well, unfortunately, that is all the time that we have for question and answer period, because we are starting to run up until 2/4 of the hour. So I'm going to have to cut it off there. But if we didn't get to your question, please know that the folks at WhiteSource and Guy will be getting a copy of all of the questions, and I'm sure he'll be more than happy to follow up with you offline. Also, I want to remind the audience that today's event has been recorded. So if you missed any or all of the event, or you just want to listen to it again, that's fine. You'll have the opportunity to do so. We are going to be sending out an email that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website, so you can always go find it there. Just go to devops.com/webinars, look in the on-demand section, and it'll be right there waiting for you. I also said at the top of the hour that we'd be doing a drawing for 3 $50 Amazon gift cards. So I'm going to go ahead and do that right now without further ado. Our winners today are Paul C., Jan W., and Emily R. Congratulations to all three of you. We'll be following up with you post-webinar via email to get your gift card over to you. Guy, great presentation. Thank you so much for sharing your information with us. Really appreciate it.
Thank you. Thanks for having me.
Great. I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I'm signing off. Have a great day, everybody.